you can find the data editor that contains a table with all the samples of the analog and digital waveforms. Let's start creating a basic waveform. On the left, there are two parameters that are strictly related to the waveform that will be created. They are respectively the samples number and the sampling rate. The sample text box specifies the total number of samples of your waveform. By default, its value is 2048, and through this text box you can modify the waveform length in terms of number of samples or duration. You can press the Samples Time button to change the waveform length representation from samples to time in seconds. The total duration of your waveform will depend by the sampling rate value and by the number of samples using this equation. Basically, the frequency of the waveforms is related to the sampling rate parameter. It is the clock frequency used to read the samples from the waveform memory. As you can see in the table below, we have one sample every 833 picosecond. That it is the inverse of the sampling rate. If you change the value in the text box, you will modify not only the time base in the Waveform Editor, but also the instrument sampling rate in the True-Arb application. Let's see what it happens changing the sampling rate from 1.2 gigasample per second to 600 megasample per second. If we return to the True-Arb application, we will notice that the instrument sampling rate has been changed from 1.2 gigasample per second to 600 megasample per second. Okay, for our first waveform, let's set the duration to 100 kilosamples and set the sampling rate to 1.2 gigasample per second. Now press the Edit Waveform button to open the standard Waveform Editor window. Using this window, you can create basic waveform like DC level, sine, increase ramp, triangle, PRBS, and so on. And for each waveform, you can modify its parameters. As example, let's select a triangle and change the number of cycles to 4 and change the amplitude to 2 volt. Hit OK to confirm. As you can see, our basic waveform has been inserted in the first row of the graph. At this point, we have to transfer the newly created waveform to the AWG. To do this, just press the Save Selected Waveform button and type in the Save As form the waveform name and a small description. As example, we type triangle test in the name and in the description triangle waveform 2 volt amplitude. The Save in the Waveform List button allows you to save the selected waveform in the True-Arb waveform list. While with the Save as Zip button you can save the current waveform in a proprietary zip format. This is useful when you work in offline mode to store waves in your USB stick or hard disk. Let's select the first option. If we open the True-Arb application and we go to the Waveform List page, you can see that the triangle test makes part now of the instrument waveform list, and it can be used in your project. To insert this waveform in the first entry of the sequencer, select Triangle Test in the drop-down list, and press Run to start the generation. The second way to open the Waveform Editor is from the Waveform List page. Select on the list the waveform you need to edit and click the Edit button. The Waveform Editor will open. Starting from this basic waveform, we are going to create a more complex one, that is what we call as advanced analog waveform. Expand the waveform app to give a better look, and let's examine together what it is an analog waveform. An analog waveform is made by basic items called segments that are placed one after the other in the timeline to create the final waveform. Each segment is made of one or more components. The segment components have all the same length and they share the same time frame. Moreover, they can be combined by means of elementary operation like add, subtract and multiply to create the final segment. By default, an analog waveform is made of one segment and one component. Now let's go into it and build an advanced waveform. We are going to create a waveform with 3 segments. The first thing to do is to leave some room for the other 2 segments. So click on the tree node to open the waveform structure, select segment 1, right-click to open the context menu and select Resize. Type 30 kilosamples in the new length text box. Press OK and the segment 1 will be resized. You can now add the second segment by clicking with the right mouse button on the segment 1 and select Add Segment on the menu. On the property window, type 30 kilosample as a new length for the segment 2. Press OK and the segment 2 will be added to our waveform. And we can edit this segment exactly like any other basic waveform. So press the Edit Waveform button, select a triangle, change the number of cycles to 4, and hit OK to confirm. I'm gonna repeat the same procedure to insert the third segment. As you can see, the final waveform is the composition of the 3 segments we've just created. This technique is useful when you have to append together different waveforms. At this point, it's time to add components to our waveform. As I said before, a segment can be made by one or more components. So let's select segment 1, expand the root node and select component 1. Right-click on it and select Add Component from the context menu. Note that the new length field is grayed out because all the components have the same length. Hit OK and component 2 will be added. Press the Edit Waveform button to change the component 2 shape from sine to cosine. By default, the 2 components are summed together. Let's change the operation by selecting the component 1 and clicking on the Edit Waveform button. Select Multiply on the drop-down list and hit OK. If you hover over the segment 1, you will notice that this segment is the composition of 2 components multiplied together. You can use this technique, for example, to generate IQ modulated signals. We are ready with our advanced waveform. In summary, an analog waveform can be seen as a list of segments where each segment can contain one or more components that have all the same length, combined by means of an elementary operation like add, sub or multiply. Last thing, the advanced waveform is considered as a custom waveform by the software. In fact, if you press the Edit Waveform button, you can note that the waveform type is custom. We can add it to our waveform list exactly in the same way we've seen before. So hit the Save Selected Waveform button, type the waveform name, Advanced Waveform, type a small description, and this time I'm going to save in zip format, so press the Save as Zip button. We have to select the folder and the file name that we're going to save. We save it on the desktop and we switch to the True-Arb application. Let's suppose that we are working in offline mode on our notebook. We save the waveform in zip format on a USB stick. After that, we connect the USB pen to the instrument, we open the True-Arb software and we go to the waveform list page. On this window, press the Import button, select the zip file, press Open, and the waveform will be imported in the waveform list. Now you can add it and use it in the sequencer. In this example, we stop the instrument to add another entry, and in this second entry we select the Advanced Waveform. Press Run to start the generation again. You can select the whole waveform simply by clicking on the waveform row on the left. You can also select a portion of the waveform in the following way. Keep the left mouse button pressed, move the mouse on the left or on the right, and release the mouse button to select the waveform region. A more accurate way for waveform selection is to use the selection start and selection stop controls. Just select an analog or digital waveform and set the start and stop values to make the waveform selection. Note that the blue selection area will appear not only on the waveform graph, but also on the data table below. In this example, I make a coarse selection on the digital line 6, and then I refine it using selection start and selection stop. I set the start to 50 kilosamples and the stop to 67 kilosamples. Press Enter and change the waveform value to 1. Now we will take a quick look to the zoom tools. Select a waveform and click the Zoom Tools tab to open the Zoom palette. Here you can find controls that offer various ways to operate a zoom on a waveform. They are pretty self-explanatory, but let's go quickly on them. The zoom in performs an horizontal zoom. The zoom out performs an horizontal zoom out, and the zoom manual tool allows you to select a region of a waveform and zoom it. Zoom All restores the zoomed waveforms to fit in the current window. You can also execute vertical zooms using the Zoom In Out vertical zoom buttons. The Zoom Fit resets the vertical zoom, adapting the waveform to the height of the graph. Let's continue our description of the analog waveform tools. The Remove button allows you to remove segments or components from an advanced waveform. Select the segment 3 and press the Remove button to remove the third segment from the analog waveform 1. Select the component 2 and press Remove to delete the second component of the segment 1. As you can see now, our waveform is made by the segment 1 and the segment 2. The Noise Filter button allows you to add noise or apply a filter to the selected area or waveform. As example, let's select a waveform region, hit the Noise Filter button and the Effect Settings window will open. Here you can select to apply a filter, noise, filter before noise, or noise before filter. Let's select noise and go to Noise tab. We can choose between Gaussian, uniform and white noise. I select Gaussian as noise type and 200 mV as standard deviation. The noise has been added to the analog waveform 1. Now let's change the analog waveform 2 to a sweep from 1 Hz to 10 MHz and apply a filter on it. Select Filter on the Settings tab and then choose the filter type. We can change the mode like FIR or IIR, and we can select the topology like, for example, Bessev, Butterworth, Chebyshev and so on. Let's select Butterworth, and the type. Let's select a low-pass filter with steady state response set to true. The cutoff frequency is 5 MHz. Press OK, and the analog waveform 2 will be filtered. Now we can modify some parameters. For example, we can change the order of the filter from 1 to 4. Press OK and see what it happens.